Hello students and welcome to CSF again. What we're going to do today is we're going to go over the challenges and what we need to do in order to approach them. Now, when you click on the download challenge plates, you're going to be able to download any type of video that you want from the folder. So we want you to do is pick two of these in order to work with. And these are different type of scenarios that you will find in a traditional film shoot, right? So we have anywhere from dolly type of moves that are very simple, um, nodal pans here that don't have any type of parallax, but then you have characters in the middle and out of focus plates, which introduce a challenge. From very nice and dramatic type of moves, where is a little bit more erratic of the camera. So it's more of a handheld shot where a lot of motion blur. That will kind of represent another challenge. And another dolly here with a little bit of an orbit as well in the center. So there's different type of challenges for you guys to work with. You just have to pick two that you like. I'm going to create two videos for two of these, and you're welcome to actually use the videos and follow along, or just decide to do all of them or your own. So let's go ahead with some of these and let's analyze some of the plates that we're going to be working with. So what I'm going to do is I'm going to start with this one called Deadly Shot. This is a short film produced here at Full Sail from some of our film students. So what we're going to do is we're going to go ahead and work with this shot. And the premise of this shot is that we have to go ahead and create, let's say, a cityscape on the outside of this window, right? Right now it's very dark. And it doesn't give a good impression that they are in an office in a high story building or anything like that. So we would like to put New York in there, right? But before we can do any of that, we have to track the shot. So for this shot, our main goal as a match mover, again, we're doing this for compositing. As a match mover into doing the compositing scenario, we could decide either to go with full nuke or we could decide to go with synth-dice. Now, because we are doing synth-dice here, and we're learning synth-dice, we're going to go with synth-dice to start the process here. And then we're going to export all the data to nuke, and then in nuke, you will be able to do your own set extension or whatever you guys want to do with it. The other thing that we have is we might need some clean plating in this shot as well. So some of the artists might need the track as well to be able to remove some of the lamps that are on the back that are kind of distracting to the shot, right? These are the lamps from the actual set. So they're a little bit distracting. They could actually pass as something on the background, but our VFX supervisor wants them removed, so therefore we might have to do a paint of that. So you might have to keep like frames from here and frames from there in order to be able to remove it and clean it up. So essentially, that will be the task that we need to work with, and that would be why we'll need to do the actual shot. So let's take a look very quick in synth-dice and see what we need to tackle first. So for synth-dice, what we're going to do is let's go ahead and show a very quick example. So I'm going to go ahead and open, let's say no here, and I'm going to go open my plates. So in this case, you should have a folder organization or a folder structure that is easy to follow. So in this case, I have my LS01. There's where I'm going to save all my files while I'm working in synth-dice, my plates that I'm going to be using, exports, deliveries, and all that stuff. Also, I'm going to put in this folder right here later on, I'm going to put a transcoding, but you will see what that means in a second. So I'm going to go ahead and load one of my example scenes there, and we're going to leave everything as default. Let's hit OK, and there we go. So a couple of things that we need to look at here is the type of camera move that we have. So we currently have a move that goes from the left side of the screen to the right hand side of the screen, and this is important to note. It's this nice subtle move, so we know it is not handheld, so it is in the dolly system, and we're tracking the actors here. So essentially, we're looking at the actors, and the camera is tracking their motion. They're acting all the way through the scene, and it's kind of an orbit at this stage right here. We're kind of focusing on this area right here, kind of following her and her actions in the shot. So if you notice some of the things that we put in this one, so in here we decided to add objects to the table to see if the whole shot was sticking or sliding all the way through. And also we decided to add an object on the wall to make sure that it was sticking as well. Now this one is not complete, it's just a quick example, but there's more things that we need to do to this in order to get it to look perfect for us in order to be able to submit it to our supervisor. The error on this one is very low. Right now I have a solver error about 0.5. It could be taken lower. And if we take a look at the quad output, quad perspective, we could see that we have a nice setup. And the camera looks like it's properly set up in the whole system. So we can see where the table is. It's nice and flat. We can see the wall where the actual element is. And we can see the angle here of the window as well. So we have the wall, the window, the table, the three main things that we need to look at as we work with. Um, so we're going to show you the process of adding a couple of geometries in here as well to be able to complete the shot. So let's go ahead and start with this process. And so the first thing I'm going to do is I'm going to go ahead and I'm going to clean up all this. So I'm going to say close, and I'm going to say no. So what I want to do is I want to start at frame 1. So if you have the newest version Synthesize, the MOV file, the MP4 file will automatically start at frame 1. But if you have an older version Synthesize, you might have to do the transcoding here. So what I'm going to do is I'm going to go ahead and I'm going to transcode this footage, and I'm going to be transcoding that footage into essentially an image sequence. So in this case, it could be a Targa, it could be a JPEG sequence. What I'm looking for is I'm looking for values to make sure that it has values in there so I could go ahead and work my magic after to be able to erase some areas if I need to track some of the darker regions. So I'm just looking at Nuke very quickly to do that. So what I'm going to do is I'm going to reset the Gamma Slammer here. I'm going to transcode this to an image sequence. So for this, I'm going to put a right node, very quick. And then in here, what we want to do is we want to send it to the same location that we got it from. So I'm going to go ahead and I'm going to click on the right node, and I'm going to browse to that location. So I'm going to go to my desktop here. You guys should have a CSF folder, lesson 1. In your case, it's not going to be called Demo Challenge. You decide how you call it. I usually try to keep it all within the same naming convention. I'm going to go to the plates here. I'm going to create a new folder. And that folder, I'm going to name it exactly the same as the name of the original plate. So this one is going to be Deadly Shot. That was the name of the movie. And then underscore, and this is 001. And then let's hit OK. So that will be our folder. Then what I'm going to do is I'm going to go ahead and paste exactly the same name of that folder as the name of the file. And if you notice, I put underscores in here. I try not to use any spaces. The spaces will actually give us problems later down the road. And if you notice, maybe some of your movie files do have spaces in them, and that could be a problem later. So try to use underscores wherever you can in this case. All right, or put the elements together. But wherever there's a space, you should put an underscore in there. All right, so now that we have that, we're going to put the hashes. We're going to use 4 hashes in here. So it starts with 0 and then the 3 elements or 3 decimal spaces extra that we need. And then we're going to create for this one, I'm just going to do a JPEG sequence. We don't have any more data in there due to save space and upload times and stuff like that. But if you're working in production, this will be a DPX sequence, and it will be really high res, as well as it will have a lot of dynamic range within it. But we're going to use JPEG for this one. Let's go ahead and hit save. What that does essentially is just allows us now to render it. Now the next thing that we're going to do is, this is basics from CFM, right? So what we're going to do is we're going to take this, and we're going to be rendering as sRGB. So it's very important that our color space is set up to sRGB. The other thing that we need is we're going to be rendering only RGB. So we don't need alpha in here, so you can leave it on RGB. Okay. It's going to be a JPEG. We want the JPEG to be full quality, so let's go 444, and then let's increase this to 1 to make sure that it's 100% its quality. Now, if by some reason you didn't create the directory, you just did what I did, that was just to, let's say you didn't create new directory when you browse the window here, you didn't use this little icon. If by some reason that happened and you didn't do that, you want to turn on create directories. What this will do is, if by some reason you just typed the location, but you never created it, this will create it for you. So when you render, it doesn't error out. So that's one of the little nifty tricks of the new version of Nuke. So what I'm going to do is I'm going to go ahead and render that, and we're going to take a look at the results. We want to start at 1. This is very important because usually in production we start at frame 1000. And then we work from 1000 forward. But later on, if you need an explanation of that, we could go over that in the class. Let's go ahead and hit OK. And from frame 1, we're going to go ahead and render the whole sequence that we're going to be working with. In this case, 136 frames. Now, it's very important that we start at frame 1 in this case, because that's what we were required from the production. In this case, we don't start frame 0, but frame 1. So if by some reason you see that your synthesize is starting at frame 0, like mine was, is because you probably were using the MP4. All right? Like I said, the newest version of Synthesize is able to offset it to 1, the same as the older version. But we try to do this first. And in production, we always work with image sequences, never MOVs. So let's go ahead and test it out very quick. Let's load the sequence. So I hit R to read. And I'm looking at the path, making sure that the sequence is located on the path. So there's my folder right there. And in there, I have my sequence. I'm going to hit open. It's important that you check it before you do anything else to make sure that you have a one-to-one conversion. We will have a little bit of loss because we're rendering back to a JPEG, 8-bit JPEG, but it's only for tracking. It's not for the compositing. So we're fine. We could actually deal with that. We have the information. Yes, we have all the data there. Good. So we're good. There's no black frames or anything like that that will introduce problems in our track. All right, so we're good to go. So make sure to do this with any of the other challenges that you will do. So let's go ahead and start with this deadly shot one. So after I do this, you could actually go ahead and close nuke, or if you need to convert another one, this will be the time to do it. So the first thing that we need to do is what you did on your tutorial, is to actually go ahead and check the preferences very quick. If you haven't done so, make sure that everything is set up correctly. So first frame is 1. Like I said, in production, this might change because if we start frame 1000, what we will do is we'll turn this off, and then we'll go down here and match image sequence frames. So in this case, I could leave it off right now because I have match image sequence frame numbers on. It will actually turn it back on. So if everything is offset, it will offset it for start frame 1000 or whatever else. So this is one important thing that you don't get told at the beginning when you're actually doing all the basics. You actually, as you progress into a production pipeline, you start getting all these little informations. All right, so the next thing that we need to make sure that we have is, let's go to the perspective very quick. Everything is set up correctly, yes. The other thing that we want is, let's go to the tracking tab. That's good. Let's go to meshes, lidar settings. We're not going to be using lidar in this class, but I like to keep it Y up, the same as Maya. And then let's keep going down the road. The user interface, also we need to keep it Y up in Maya. And like I said, this is just a quick check to make sure that everything is set up like you did at the beginning. If something is different, go ahead and change it, and so on and so forth. And our exporter is nuke. Okay, so we're good. Let's hit OK. So for the import, what we're going to do is we're going to go File. We're going to say Import Shot. Then we're going to go ahead and grab the image sequence, not the MP4. I'm going to select that, and we're going to hit Open. All right. So this image is actually 1920 by 1080, but the frames per second is tricky because now we have an image sequence, which is a little bit of a problem. It doesn't tell us exactly the frames per second. So right now it's defaulting to 24 frames a second. In reality, this image is 2997. So if we click on NTSC right here, you will notice that it will change to 2997, and that's actually the original frames per second for this one. If you're unsure about that, if you check a nuke, right, and if you have nuke still open, or if you go back and you reopen nuke, you could actually go to your default file or folder in there, and there's a metadata section here. And you could actually check the metadata for this. This is extremely important as you work in production. And you could see the color spaces, you can see the decoder, how it was compressed, and then the frames per second. And we could see that we have a 1080p sequence at 2997. So this is extremely important if you're going to do this type of setup, because if you screw this up, everything else, the edit, the CG, everything that gets rendered will be screwed up, even the track. So it's very important to make sure that you match those numbers. All right, so we're going to go ahead and make sure to match that. That's good. Our aspect ratio is 1.778, which is great. Backplate is our sensor size. You could keep it at the default 24.892. Some of you might have 36 in there. It all depends. As long as it's 1.778, so far we're good. This plate won't have any rolling shutter, so we're good with that. So you could keep it all default. We're not using any stereo or any VR. So after we have all that, hit OK. So now we're ready. Everything is cached. Okay. And now we're ready to start. Now, I know the temptation of this, of hitting that auto and letting it go is really high, but don't do that. Kind of stay away from that. We're not going to be working with that setup. The other thing that we're going to check also is, as we're working, is the lens distortion to make sure that everything is working correctly. But the first thing I'm going to do is I'm going to go ahead and check what do I need to do here. Maybe the auto track will be a great scenario for this. but I might want to track some of these elements manually. In order to evaluate what type of trackers are good, right? There's a couple of areas that we want to look at. We want to look at corners. Majority of the trackers work with a corner detection algorithm as well as feature detection based on those corners and those edge details. Mostly the change in direction on the pixel. So if we see a change in direction of these values from here to here in this area, and the pixel as it's moving is showcasing those changes in direction, we could actually take that matrix right there and say, okay, it's moving in this direction, so we could follow that feature. So what we're going to do is we're going to keep it basic. I'm not going to give you too many explanations on that. You got some of that at the beginning. But we will delve a little bit more when we do lectures or go to meetings and so on and so forth if you have more questions about it. So let's go ahead and start with the challenge here and add some of these trackers. So for this, if we were doing any type of automation, we will have to rotoscope her, right? She's pretty much moving through the frame, so she will introduce a lot of problems, the same as the other characters that are moving in the shot. So that's why I prefer to do a manual tracking for this. But again, a automated will work pretty well. You just have to do a little bit more cleanup as well. So let me go ahead and start with that. So one of the things that I like to do is I like to go in and I like to click on the features here. I'm going to blip the playback range, and I'm going to see what the computer detects, right, for me. And I see that the computer has a lot of good, useful trackers that are pretty solid across the board. So I know those corners will track, I know those areas will track, but I see a lot in these areas that are no good because there's shadows, there's a distance between those elements, and there's parallax between those shadows. So these areas are no good, and I know the automated tracker is going to calculate those areas, but we have a lot on the wall because we have a nice patterns in there, and we have a lot of corners in the scene. Now the table is a little bit empty, and if you notice, the auto tracker is also kind of detecting all these elements that are actually reflections, and that will be a lot of cleanup that you have to do. For this, what we're going to do is I already saw kind of the evaluation of this. Let's go ahead and clear the blips. And what I want to do is I want to quickly go in and I'm going to go into my tracking room. These are called rooms. In other softwares, they call them tabs. So I'm going to go into the tracker room or tracker tab. I'm going to hold down the C key on my keyboard, and I'm going to go ahead and start tracking one of these elements. So what I'm going to do is, this is a pretty nice soft movement. So what I want to do is I want to just kind of keyframe these guys every 3 to every 5 frames. And I'm going to do a key smooth by 5 if by some reason I need to clean it up. This won't take effect until you actually go to the track menu and then you go pre-roll by key smooth. So when you click on that, then this feature is now enabled. So therefore, when you hit spacebar, it will go back 5 and then track forward 5. And again, in the lecture, I will explain that a little bit more or in the go-to meeting. So if you notice, I track right on the middle on purpose. So what we need to do is here, if I need to track backwards, I'm going to go ahead and make sure that I'm tracking backwards here. So I want to make sure that I change the direction of the track, okay? So that's what I'm going to do now. I'm going to start from this location right here on purpose, and I'm going to extend the search region. I'm going to extend it based on the motion. So in this case, the motion is a little bit more left to right. I don't need it up and down. It's not jumping that much. So left to right. And I want to make sure that this pattern stays within that search region in a frame by frame basis. Okay, so if the camera moves a little bit slower or a little bit faster, it always is within that search region so it could capture it. The other thing I'm going to show you guys here very quickly is going to the tracking modes. There's different type of tracking modes that we could use. And in this one, I'm staying with the steady camera. But if by some reason I already have a couple of these trackers in place and they look good, or I have a shaky type of footage, I could change it to handheld sticky. For shaky footage, this one works a little bit better than the steady camera. So this is one of those things that you want to pay close attention to and kind of experiment with it as well. Handheld use others means that I already have some trackers in there, and I'm using those trackers to help the new trackers that I'm creating throughout the setup. So I'm going to go ahead and steady camera is fine. And let's go ahead and track backwards. So what I'm going to use is, I'm going to use shortcuts for this. So in order to create a tracker, I hold down the C key, right? And that's how I create a tracker. Instead of going over here and clicking on this, creating a tracker, and then clicking it back off, the C key is a lot faster in order to create that. So C as in Charlie, hold it down and create your tracker wherever you need it. The next thing that I use, the next shortcut that I use is the A. It will go back to that keyframe there. So it jumps from keyframe to keyframe backwards. And F will do the opposite. It will jump forward from keyframe to keyframe. This will be very important later on as we start tracking. You will see why. The other one that I like to use a lot is the S and the D key. The S key allows me to track one frame at a time by hand going backwards. And because I have this auto key every 5 frames, automatically it keys my frame. And what it's doing is actually holding the pattern or grabbing the pattern again. So that's the reason why we set keyframes, is to make sure that we re-grab that pattern as we're going through. So let's go back and let's keep tracking this guy. I'm using, again, the S key to go backwards. And you notice how we're holding that, but you see how it's getting out of my way right now? It's kind of going towards the edge of the frame, and I probably will lose it, and I want to still see what I'm tracking, right? So a lot of people use this window, and that's perfectly fine, but if you want to see it in both, one trick that you could use is to actually hit the 5 on your keyboard. Essentially, it's also the equivalent of going to your track and pen to follow. So it's following along with the tracker, so it's kind of stabilizing the tracker in the center of the screen. Okay, so as we go through it, we keep tracking, and you notice how it's very stable. If we see any jump in here or anything like that, we know that there is a problem with that tracker. And I'm looking at the pixel here, make sure that there's no pixel shift or anything like that. So that tracker is great. So I'm going to set a keyframe right here. I'm going to flip it around. I'm going to go back to this guy right here, and I'm going to flip it around to the other side. I'm going to hit the D key. Again, what we're trying to do here is just showing you different type of tracking operations, right? Using the shortcuts and going through that process. I'm going to hold down the D key all the way through. And you're going to notice that right here we might lose that tracker, right? Because she's going to cut through. So hopefully not. But let's see. So I'm going to reduce the pattern region here. All right. And let's see. We're going to lose it right there. So we notice right there she's going to go through. So what do we do in that scenario? We actually turn that tracker off before she actually even touches that pattern. So I'm going to go ahead and I'm going to set a keyframe right here, and I'm going to turn that pattern off right there. So now it's not tracking anymore that corner. And that's fine for us, okay? So right here I have an extra frame that is bad, right? So what happens when we have something like that? If you're tracking, you turn the tracker after the fact, right? Thinking that it was good, but all of a sudden you have like that jump in the frame. You have two options. One, you could actually go ahead and manually go in and fix it. But when you do that, you have to jump back to the first keyframe that you have there by going back and then retrack forward, okay, in order to smooth that transition between those two keyframes. If you don't do that, you will have a sharp jump in here. So I'm going to go ahead and change this as we're tracking to camera and graph, so you could see how the tracker actually is moving from frame to frame for frame. So what we want, what we're looking for, is this nice smooth curve all the way through and no big jumps or anything like that. And by some reason this tracker was like way up here, you will notice that jump very quickly on your graph. Okay, and this is X and Y position, right? So it depends how you're moving this. Your X and your Y, or U and V, are actually moving with it. Okay, so our job is to kind of keep this as smooth as possible throughout that whole process, and that's why we do that. So I'm going to hit undo very quick. So I go back to what I had, and I'm going to go back, make sure that I have my nice smooth transition and there's no jump. So after we do this, it's very important. I'm going to go ahead and turn off that keyframe right there. Let's go ahead and shut it off. Let's take that, turn that off. I'm going to go 1 frame back, turn that off too. Actually keep that keyframe. And so what we're going to do next is we're going to go and check, right? But one of the things that we don't want to do is, as we're tracking, we don't want to go back and check without having locked our tracker first. If you forget to lock your tracker, you could actually screw up the whole tracking setup right here, okay? So we have a pretty good track. It's really decent. It's nice. It holds all the way through. The smoke doesn't affect it. Her doesn't affect it or anything like that. So let's go ahead and unlock the pan to follow here by hitting 5 again, so we could actually move freely now on the setup here. And let's go ahead and keep tracking some of these other guys around. So hold down C, click, and let's go ahead and track this guy until we lose it completely. So I'm going to pick up a little bit more of the pattern here. We are 5 and 5. I'm going to track it forwards first. Again, I'm making sure that my arrow is facing forward, the direction of the track. And what this one is going to do for us is it's going to hold it, right? I'm going to hit 5 to make sure that it's on the center. But if you watch her, right, she's actually completely obliterating that first tracker that we had. But this guy, we're making sure that it still holds the information as we move through. Now, I got to check here to make sure that we didn't had any big jumps or anything like that, and it stays pretty much relative in the same location as we move through. Now I'm going to go back to the first one here that we tracked, and then I'm going to change the direction of the track, and I'm going to track backwards. I'm holding down the S key to go backwards until we lose the tracker, right? So let's go ahead and hit spacebar, and let's see what happens when we lose that tracker, if we ever lose it. So we were in luck. We never lost the tracker. It never went out of frame. But if by some reason it goes out of frame, you will know out of frame. You will notice that it will actually turn off the tracker sometimes automatically. Sometimes it won't. And when it hits the wall here, when it hits the edge, we call that a cliff. And you will notice that this little guy will turn on if something happens and it's reaching that edge. Like I said, sometimes it does it perfectly, sometimes it doesn't. So let's go ahead and lock this guy. That was perfect track right there. What is the minimum? A lot of people ask, what is the minimum amount of trackers that you need? Well, you notice this color's down at the bottom on the graph. We need to make sure that that graph changes to green, then to gray. When you hit gray, you have all the trackers that you need, enough and more of the trackers that you need. When you hit green, you have the minimum, bare minimum amount of trackers that you will need in order to work with this shot. So those are the things that you need to pay close attention to. Now, the other thing that people ask is, Pedro, why are you putting these trackers on those locations, right? What makes them different from the head of the guy or the window? Well, these are trackers that are stable, are things that are not moving or changing in shape or form as they're moving through the timeline. So they're going to give me really good solutions in order to be able to track the shot, right? Now, when we have this obscuration right here, right, where the character occludes the element that we're trying to track, you will see what will happen with the tracker. You see that we lost that tracker, but it never turned off. It didn't detect that as a cliff. It wasn't hitting the edge of the frame. Now watch that right there, and you notice how this tells you right away there's a problem with the track. So you could actually judge the track even before it has finished its job, right? So right here, up to here, we're doing pretty good. Up to that keyframe, then we lost it, right? So I'm gonna go ahead and shut it down right there. So I'm gonna set up a keyframe right there, go to the next frame, and I'm gonna shut it down, boom. Turn off all that data after that. Now, what I'm gonna do is I'm gonna do an occlusion track. So when an object gets occluded, you have the chance to re-grab that again back here towards the end. But you have to decide if you do that or not. So let's go ahead and turn this guy off. We're getting some jumps later, but just because we haven't re-grabbed the pattern. So let's go ahead and do this. So you notice that we stayed right here. So we have two options to kind of track occluded. So I'm going to use the first option here that is actually going in and clicking on this tracker right here. I'm going to use what we call a Z drop because I have that tracker selected. You could either click here and move it into place, or you can hold down your Z key, or what you guys know as Zorro or Zulu, right? What people use for Z depth, right? So when we're recording these, my accent kind of confuses and people think it's the S or the C. So this one is the Z. So essentially Zulu. So we're going to hold down that letter and click in the same location where you left off. Okay? So if you need to verify, you could always go back to the initial keyframe and see where you left off. And then when you go to the end, you could see, okay, I'm a little bit off on that. And then how you check for really quickly that you're actually on the spot. Well, for that is the A and the F. Remember that I showed you that a little bit ago? So if you hit A, you go back and you could check where you're at on that scenario and see if you actually are matching and you're leveled. And we're pretty much leveled there. So we're pretty good. We could see the little corner right here, and if you can't see the corner, you could always increase the brightness levels of your shot by clicking on this little plus and minuses. So you could actually see where you're at on those scenarios. So I'm going to hit the A and the F to check. And I'm checking the distance between this element right here. I'm checking the distance between this element. So we're pretty good right there. And we're really good at the bottom. So we're good to go. So now what I'm going to do is I'm going to carefully babysit this guy as I move forward on the track. So nothing in the middle is getting tracked, only those two areas. So I'm going to hit the D key to continue on my track. And you notice that it's nicely holding on. And I'm also evaluating this window over here to make sure that it stays. So I'm going to hit 5 very quick to make sure that it's on location. Okay. And as we go through, I can hit spacebar here to completely finalize it. So let's go ahead and lock it off. All right. And you're going to continue doing that until you have completed the majority of your track. Okay? So try to find locations where you could actually go in. Hit 5, by the way, by some reason you're stuck. You want to find locations where you could actually complete the track as quickly as possible. So here, I have an occlusion right here as well. So let's go ahead and show a different technique for that occlusion. I'm going to wait until she's actually occluding this corner right here, right? So she's right there. So I'm going to start my track right on this location. I'm going to hold down the C key, click on that. I'm going to hit 5 to lock it, but I'm going to track backwards to the beginning. So I'm going to flip that because I don't want her occluding anything. I'm going to hit spacebar. All right, it's perfect track. Let's lock it. But this time I'm going to do it a little bit different. When she crosses by, instead of using that same track, I'm going to hold down the C key. I'm going to create a new tracker. And then I'm going to track forward from that location with a new tracker. And what we're going to do is we're going to do a combine selected trackers in order to get these two trackers to combine the data. So I'm going to hit spacebar. Let's see. Let's hold that. The pattern is holding great. So you notice that some areas already changed to yellow. That means we are getting close to having the minimum will be about 8, the bare minimum. The good number will be 12 to actually go ahead and get it a nice, decent track. So now that we have that, we're going to lock it. But this time, I'm going to hold down, click on that tracker that we currently have. I'm going to click on the previous tracker, tracker 4, right? And you notice that there's data here and there's data here, the two areas that I tracked. So what I'm going to do with those two trackers selected, I'm going to hit 5 here to unlock my window. With those two trackers selected, I'm going to go ahead and combine them, okay? So I'm going to go track, combine selected trackers, boom. Now that I have done that, you notice that the data will be here and then it will be here, okay? So go ahead and start tracking a couple of those elements. I'll see you back when you have a couple more in there. I'm going to speed it up so you are not waiting here for me to track all these stuff. And then from there, we're going to take it back on. Okay, right here, I want to stop it very quick. And you will notice that as you keep tracking, right, you keep getting the screen, the yellow, the red. And this will give you indications where you need to put the most amount of effort as you're tracking. Like right here, we have nothing. So we have to make sure that we get something in this location right here to try to start getting filling up that area. Now, I don't worry too much because the areas that we need to work with is the back here, this frame right here that we need to clean up, and then the table to kind of work out any of the issues. But what we're going to be doing is as we continue tracking, I'm going to speed it up again. I'm going to continue tracking a couple of more elements to kind of fill up these gaps right here. And then when we're all done, we will retake it back. Okay, so let's go. Okay, so we're back. So essentially, if you notice, we've been tracking a couple of things manually, and you could see the graph filling up. Now, at this stage, we could actually solve the shot, and we could get a pretty good result of all the elements that we're working with. I would like to track one more here, like about the crown glass, somewhere around in this premise right here. Now, one of the things that doesn't move in here is the shadow. So I could actually go ahead and track that shadow to kind of get a little bit of that parallax that we're getting in the foreground element. So let's go ahead and hit 5 here very quick and see where that shadow takes me with the smoke, right? So I don't want to track that up to there, just a little bit there. And you see how we filled up that area, but you could see the spike right there, right? Where we start getting the smoke into the screen. So I'm going to go ahead and shut that one off there. And let's track it a little bit backwards as well to kind of get a little bit more of that setup. So let's switch the direction here. And let's go back a little bit, but we're losing a lot of the quality of the footage at that point, so we might be getting a little bit of slide. So one of the things that you could do is, that we haven't talked about, is the weighting of that tracker. So if you still want that tracker, but it's not that great, you could actually reduce the weighting of it, but you got to be very careful. After you reduce this weight, the next one that you create will have the same weight. So I'm going to go ahead and reduce this tracker so it contributes to the solution, but it contributes about half of its weight. So essentially, it's not going to be the one that is going to be looked at like the most in order to achieve the solution, but it's going to give us some information in there. So if it has a high error, it wouldn't be contributing that much to the rest of the shot. But if you notice, we have one in the grapes. You could track a couple of the grapes. Like I said, this shot tracks pretty well in auto. But the idea is to kind of get the idea and how things work when we don't have that auto solution and kind of figuring things out on your own. as well. So it's a matter of kind of keeping up some of these elements. There's a lot more that you could track, but what we're going to do is right there. We're going to leave it at that, and then we're going to go ahead and start with our solving for this setup. So what is solving? Well, solving is the process of converting these 2D tracks. So all this that we did was only X and Y axis, right? We track into the 2D view. And now we need a way of converting this from 2D into 3D data. So we have to take all these points and interpolate them and say which one is moving faster, which one is moving slower, and based on that, kind of find the location where all of them intersect to find the camera, where the Z of that camera is. Then from there, after we get the camera, it's actually getting the points distance from that camera as well after the fact. So we're creating this full 3D environment out of this 2D approximation. So let's go ahead and do that. So for this, we're going to take the solver panel, right? So we call them rooms again. So you know, by some reason you listen to these and people are calling them rooms. That's what they're called. And I'm going to go to the solver panel and I'm going to tell it. I'm going to help Synthesize figure things out. Oh, if you notice, I have one right here that I didn't lock it. In order to lock it, you could always go ahead and click on this little lock button, and you want to make sure that you do that. And that one only lasts a couple frames, so I don't think it's going to be a good solution. So I might reduce the weight of that one to like about 0.7 for that. Um, we could track also on the chairs. That will be probably something that we'll track in a second to see if we can have a good solution. But I want to show you something first. So let's go to the solver. And then on the solver, because we track very limited amount of trackers, we have very few, right? What I want to do on that solver is I want to go ahead and tell the solver, instead of automatic, that is what you've been using so far, I want to tell the solver, instead of on director, sorry, that is what you've been using for, I want to tell the solver the camera direction. So I want to help the solver understand what is the type of camera that we're using here. So we said this camera is actually mounted on a dolly and we're kind of orbiting, right? So at the same time we're moving left to right, we're orbiting a little bit. So we know the direction. We know we're going towards the right. So we're going to help the solver tell him, hey, I'm going towards the right. So that's one of the ways that you can help the solver. The other thing that we're going to do is we're going to go to the calculate distortion and we're going to turn that on to kind of see if we could kind of figure some information out of this one. All right. So now that we have that, let me go very quick to the tracker here, make sure that I don't have any extra data that I don't need. There we go. Let's go back to the solver. And in the solver here, we're going to do is we're going to go ahead and after we set up those preferences, we're going to hit go. And what it's going to do is going to go through the process of calculating all that information and giving us a good solution back. So now with all this in place, notice that I don't have thousands and thousands of points in there and automatically I already have a really good solution that we can understand. The camera is moving left to right, which is actually the direction of the movement. And you notice that every single one of those points is actually referencing a location from there. So you could see the wall right here. This is where this element is, and you could see the window area right here. So if I go ahead and I select any of these points, we could see that those are the windows, and if I select any of these, we could see that those are in the wall. So if we select these four that we put on the picture frame, you could see that they're right there. So we did a pretty good job. You notice that these are inside, so there it is. So those are creating those types of scenarios. So the other thing is I wanted to see where the table was, so I created just these 2 points in there so we could see that they are actually coplanar, which is great. One of the things that you have to learn is because we're averaging pixels, right? It will never be a perfect straight line. We will have to add a couple more points in there to kind of get a perfect straight line. You're going to have like a shift going up and down, up and down, up and down. So you got to be very aware of that. The same with top to bottom. You could get as straight as possible, right? But they're not going to be perfect. You're always going to see this kind of sway here and there because, again, we're trying to average pixels, which include noise and all these other aberrations. So it will never be perfect, but you will get it pretty close. So the next thing that I'm going to do is let's go ahead and orient this setup. Now, there's an issue with this setup that we have to talk about, right? In the first tutorial, you actually went ahead and set up this, the coordinates with a constrained system. You selected the origin, then you went ahead and selected an x-axis and a y-axis. But there's a problem here. We don't have that, right? Even though we have this table, there's no points on that table that I'm tracking. I only have this point over here that is not that great. There's really no origin here. I have that one in the corner that we could consider kind of an origin, but it's not perfect, right? You could see that it's pretty much in the coplanar scenario, but it's not perfectly aligned with the rest of the stuff. Um, so, so for that reason, we might be able to use them, but it might not be a perfect solution. So we might want to kind of explore other areas as well. So what I'm going to do is I'm going to select this one. And I'm going to at least establish like an origin, something that is on the center of the world that I could actually ground everything towards. And then I'm going to show you a little bit of a different technique to kind of constrain all these elements together. So let's go ahead and do that. So because I don't have X, Y, and Z, I cannot see the corners of this table, so I'm not able to track them perfectly. Um, I have this one over here that I might be able to use, but then I don't have the other one over there. So I'm just looking at where the plane of these elements are. So let's go into the perspective view here, quad perspective. So that way I'm going to hit 8 in all these windows to kind of see where we're at. So the first thing that I need to do is I need to establish my ground, right? So I need to establish the grid plane here. So I'm going to lock this view over here so I could see it. And if you notice the grid right now, again, I'm in the quad perspective. The grid right now is really high. That means we're low on the world. We're beneath that grid. So if you see this white line right here, the camera's beneath it. So we're looking under the grid. So our job is to place that camera over that grid and at least get the grid to be planar with the table that we got here. So for that, let's go ahead and kind of set up an origin and see if that gives kind of alleviates a little bit of the issue here. And from there, we're going to take it on. So what we're going to do is we're going to go to the coordinate systems. That's what we're going to be setting. And I'm going to select that point right there. And you have two ways of doing it. One, I'm in the quad view now. It switched to quad view. I'm going to right click coordinates and you can set this at the origin. That's one way of setting it up. Now, the other way of setting it up is to actually select the point that you want to set up as a coordinate and coming to the toolbar here and go to unconstrained and change that to origin. Those are two ways that you could actually really quickly set up the origin for the shot. So now that we have done that, because we made a change, I want to make sure that I didn't set up two origins. Yes, I did. You got to watch out that you don't select multiple elements. And again, I'm going to leave this mistakes in here because the idea is for you guys to see how you fix them. Right, in this case, I selected two origins right there. And if by some reason I solve this right now, that would give me a really bad solve because it's saying, hey, you have 2 0 points in the scene. That cannot be, right? So you have to decide which of the two you want. And the one that you don't want, you want to make sure that you remove it from the calculation. So I don't want this one on the corner. That's too low back there. And you cannot trust anything on the edges here. So I'm going to go ahead and say unconstrained to make sure that we remove the constraint. So in reality, what I did was just make sure that there's no seed in there for us to constrain. So you notice that the constrained ones have this little blue in there as well. So from there, the next thing that I'm going to do is I'm going to establish some of these as kind of ground. We know they're like this one. We know it's in kind of the level of the table. So we could probably tell that one that is on the ground. But what type of ground? Well, we always want the Z direction to be away from us. So let me see if I have something here to write down, but no. So essentially we want the Z direction to be away from the camera, always away from the camera. So the X should be left to right, right? So in this case, this is around that XZ axis. And what we mean by XZ axis is if we look at the quad perspective here, that point, if we actually look from the top view, right? This will be the Z axis, this will be the X axis. So that point right there, we could set it as on the same plane or in the same floor as that XZ axis, okay? So we're not establishing is X or we're not establishing the Z. We're just saying is floor. Based on the origin, that guy will be also on the floor. So let's go ahead and do that. In order to do that, select it. And again, you can right click on that point, go to coordinates and set it on the floor. That would be one way of doing it. The other way of doing it will be to go to the unconstrained tab here. And this one is a little bit more tricky because you have to know the actual plane that you're on. So we said is XZ because we're working Y up. All right, XZ plane. So let's set that up. Boom. And now that one will be established now as a floor plane adjacent to that or coplanar to that origin that we set. Now, The other thing I want to show you is when you click on an origin, right, you will see that little yellow little element there, right? You will notice something went to the center here, and it's yellow in color. That's called a seed, okay? And what that allows us to do is to kind of lock the coordinates of where that point is going to be in space. So right now, my origin is over here, and the seed is saying, hey, you're going to be 0, 0, 0. So essentially, we need to establish where that location will be. So we go and we look at those things, we will be able to kind of solve it a little bit better and understand what is happening to the whole scenario. So let's go ahead and do the solver again. So anytime that you make a change, you want to go back to this. And if you notice, our error is really, really low. We are 0.3 already because we did a supervised track instead of a automated track. Now, let's go ahead and hit go very quick. Boom. Now you're going to see that the whole scene reoriented itself. Now we have this on the floor. It makes a little bit more sense, but the horizon doesn't make sense to us whatsoever. And the reason for that is because it's trying to let's do that. It's trying to look at this point, and it's trying to look at this other point, and we don't have any other ground point in there. And it's trying to establish, hey, you know, is this really there? Yes or no? And it's actually kind of bending and moving everything around. So what we want to try to do is we want to try to find another point on this setup to see if we could fix that problem, right? The other thing that we have is that C didn't solve correctly. So if we look at the perspective view, we notice that origin was not actually set up properly. So no matter what we do, we continue to resolve this, we're going to have some issues. I'm going to go ahead and do another refine to see if it gives me a better solution. And we're going to hit OK in there. And you notice that now the seed, the inverted triangle, is one on top of the other. And that's something more along the lines of what we want to see. So you're going to have to try a couple times, do trial and error on that in order to be able to do it. But we could see there's a definitely offset in that calculation there. So right here, for a little bit of short period of time, I could see the sliver of that corner. And what I'm going to do is I'm going to go back to camera view, and I'm going to see if I could actually track that corner, and then with the first one that we have in that corner there, see if we get something else. The other thing that I'm going to look at is I'm going to look at the table. I'm going to see if we can find anything on the table, anything extra, a piece of dirt or anything like that that we could actually track in order to keep that table. It seems like we could track a little bit of that shadow of the grapes. Um, a little bit, yeah, we could actually track a little bit of the shadows of the grapes to kind of get them along those lines. But let's go ahead and do that. Now, so I'm going to go to the first frame right here. I'm going to hold down C. I'm going to click on that. All right. And from there, let's go ahead and track forward a little bit. I'm going to do it every 3 frames so it grabs a little bit quicker. And let's see if we can hold this shine right here. And it's a shine, so you have to be very careful. We know there's a corner there. That's why it's creating that shine there. So this is kind of breaking a little bit with the rule, but I'm going to track it just a little bit more until, you know, I get, that's kind of leaving already the frame right there. So I'm going to kind of hold it off up to there. And I'm going to turn off everything, and I'm going to kind of do that for this one. I'm going to go back to the solver panel, make sure it's on refine, and let's hit go again. So now that I have that, I'm going to check these guys to see if now they're a little bit more coplanar and see what we get. There's one there that has about a 2 in the error, so we're going to check which one it is very quickly. Quad perspective, and we can see a little bit of that plane, but still, you see that there's kind of a slant in there. So it's telling you there's a little bit of a shift that we need to work with. And it's actually correct. If you look at it, the camera's straight on, right? But in reality, we're not straight on. We're a little bit higher looking at that setup. So, and we're looking down a little bit. Let's see. So the horizon actually should be a little bit higher right here. So let's go ahead and try those 4 guys and see if we can get something that works a little bit better for us. So that's the corner. Let's see. That's that corner that I don't like. But let's go ahead and try that. So I'm going to select this guy right here also. And I'm going to set that one as well to floor. So let's go to the coordinate system. With that one selected, let's set that as XC plane. So we're going to do any, and we're going to change this one also to any. And what that means is it's gonna try to do its best judgment of in what quadrant of this XZ plane it will be. Okay. So by changing that, let's see if we get a better result now. So let's go to the solver, hit refine again, hit go, and you notice something happened. It kind of oriented itself a little bit better. Um, Not perfect yet, nothing that I will like, but it's a little bit better. So the last resort is to actually go ahead and we try to manipulate this as much as possible by hand. But I'm going to try one more of these, and I'm going to go XC plane, and let's go ahead and solver, refine it again to try to get these guys as close as possible to the ground. Now, if you notice, everything kind of offset it a little bit because I'm trying to push those values to kind of be coplanar, and right now that's not going to help very much with this. So that's one of the things that we tend to look at as we're going through these guys. So let's go ahead and lock the camera again. And if you notice, it didn't fix horizon, didn't fix anything. So in reality, those orientations and those points that I'm using are not that great for that type of orientation. I'm going to take out this one right here, the one from the shadow, because I know there's a couple problems with that one. So in order to take it away from there, again, you select the point that you want to unconstrain and you click unconstrain. Now, anytime that you do that, go back to the solver and refine. And you notice how everything kind of orients back to itself. All right. I don't like this one either, so that one we also will probably unconstrain it as well. So let's go ahead and that's the one in the corner. We unconstrain it, and let's go back to the solver and hit refine, hit go. All right, so the next thing is, let's say none of that works and you can't get it to move it. Now, this will go a little bit quicker as you work with these. Now, there's another method that you could use, and you could base it off a wall or anything like that as well, because you could say those are constrained to the wall in the black or anything like that. But what we're going to do here is we're going to use just plain eyesight for this. So the trick that I'm going to use is I'm going to go ahead and I'm going to go to the perspective view. I'm going to create a plane that will go kind of along the lines of that table. Okay, so what I'm going to do is I'm going to take very quick. I'm going to go to the 3D tab, and I'm going to go ahead and create a plane. I'm going to create a plane right along these lines right there. So let's go ahead and quad perspective. Right where I think the table will be, right? So I'm looking at this corner right here, right? And I'm trying to see if I could see any of the table elements in there. And I'm going to move the table just a little bit further back to kind of get it on the corner that I see there, right? But also I want to see it on the perspective view, and I want to make sure it looks like it's correct. And if you notice here, we know that the table is not correct. So I'm going to go ahead and rotate that table just a little bit like that. I'm going to try to get that perspective going. And again, this is another trick that you could use. I'm going to try to get that whole perspective shift going with it. Okay. And then there's also all shifted there. So I'm going to rotate it on the side view here by clicking on it. I'm just going to rotate it to kind of match that perspective a little bit better. Right? So if you notice, I'm going with the perspective here, with the perspective there, and kind of rotating it around until I get something that kind of matches a little bit better the perspective of the shot. I'm going to hide the grid in here. So one way of doing that is you could right click, you go grid, and you could hide the grid by hitting G on your keyboard. And that way you're a little bit easier to see what is happening with the setup. So now that I look at that, I'm looking at the perspective line there, the perspective line there, and you notice that the whole world is actually kind of slanted. So what I'm going to do now is I'm going to force the world to actually go with what I told to, like in this case, the orientation of the whole table here. So in order to do that, after you have everything placed the way that you want it, you could go to scripts with the plane selected, go to scripts, and then you're going to say make mesh the ground. And watch what happens with the whole scene. Boom. Okay, so now we have the scene reoriented, and now everything is kind of matching in the sense of the ground plane. So we use a cheat in order to take that plane and kind of orient it a little bit better to the rest of the setup. Now, you want to do this after you're sure that you refine your errors and everything else is taken care of, because when you go back and you do a refine and you hit go again, you see how everything gets messed up. So essentially, you kind of lose what you've done. Those are little things that you're going to encounter. So that's why I tend to do this towards the end of my setup when I'm sure that I already fixed all the errors, all the mistakes, and everything is now good to go. So now that I have my table in there, let's go ahead and create some geometry on the background as well. So I'm going to select the 4 points here. I have these points right here from the frame that I want to use. So let's go ahead and lasso some of those trackers. Let's go camera very quick. I want that tracker, that tracker, that tracker, and that tracker to tell me where the rest of the environment is, right? So those are those 4 trackers. Now you could click also lasso trackers here to kind of lasso the trackers that you want to select as well in the perspective view, okay? You don't have to change to other views. What you want to make sure is that you don't lasso the trackers that you don't want on your selection. So, all right, so now that we have those 4 trackers selected, I'm clicking back on navigation. I'm gonna lock this guy again. Um, I want to go ahead and let's do a little pan here. I want to go ahead and create something based on those 4 trackers. Now, because we actually kind of center it a little bit more, and you notice that now the trackers line up just a little bit better than before. So it's time to save. So I'm going to go ahead and save as. I have already 2 versions. If you have the autosave on, it tends to autosave every 5 minutes, so on and so forth. It will ask you. So I'm saved version 2 already, so I'm going to hit save and replace that. So now that I have this, everything is saved. It's the next stage. Let's go ahead and do a little bit more of addition of the 3D geometry. So we're going to take the plane there. And you could create the plane like this by looking at this and try to create it, but it creates it on the center of the world. So I'm going to show you another trick here. With those 4 points selected, you could actually we could actually right click, and we're going to turn on some toolbars here. I'm going to turn on the mesh bar, and I'm going to move it down here so you guys could see it. So in this mesh bar, what I'm going to do is I'm going to activate the add cards feature. And what that is going to do is, based on my selected points, if I click and I drag, it will create a card that passes through those points. Okay? And that's kind of an easier way of actually getting something already kind of stuck in the view, right? And there you go. So if you did a good track, that thing will stay, and now anybody that uses that card right there that we created, that geometry to the clean plate, will be already tracked in place and stable. Now, the other thing, that's why the importance of tracking. The automatic tracking won't give you that. The points will be more scattered. So when you do supervised track, you know exactly the points, where you put them, and why you're doing that. So I'm going to go ahead and kind of, we could do a similar situation for the window, but for the window, we never tracked the whole frame. But we have a couple points in there that could help us figure out the problem as well. So let's go ahead and kind of select these points right here, the ones on the frame on the wall and that one. We could use some more, but that's pretty much about a good as we're going to get it. You see that they're lined up pretty well. So what I'm going to do now is I'm going to use the pan here. I'm going to move it a little bit. I'm in the 3D view. And now I'm going to use the same technique to add cards here. So what I'm going to do is I'm going to add a card right here on the window where I know I need to do the window replacement. And you notice how cool that is it's perfectly lining up with that scenario. So now that we have there, we have the window, we have the table, we have the background there. So everything is lined up and ready for the next stage in production. So I'm going to go ahead and save this. I'm going to go save as. It's version 2, so that's the latest one that I have. So replace that one. You can save it as version 3 if you don't want to save over that. But so far, so good, and that's pretty much it. The next things that we need to do is add some more zero-weighted trackers if we need it to kind of locate some features. But in this case, everything depends on the shot, right, and what is needed. So what I'm going to do is I'm going to colorize a couple trackers, kind of add some of the lines back into these guys so you could see the grids setup and so on and so forth. So let's change back to just perspective so you guys could see it. So essentially, I'm going to go to view again, turn off cartoon mode. That way we could see the wireframes. And now we're going to reduce the amount of spans that we have. So selecting the geometry, you could go into the 3D tab, in this case the 3D room, and with the geometry selected, you could click on this little number or hash in here. When you click on that, it will give you the number of spans that each of these will have. So you could give it the amount of number of spans that you want in order to represent this window. So I'm just going to go ahead and very quick just reduce that amount like that. And that gives me a better idea on how the window stands. I'm going to click on the other one right here. It's the same idea. That one's already active. So I'm going to go ahead and just do that just a little bit. We don't need to see that many spans. Sometimes it tends to get confusing, right? So I'm just going to keep it simplified in order to get the perspective view correct. Okay, so our next step will be to go through the process of colorizing the trackers. So the idea of colorizing the trackers to be able to identify when we send this up to any other match move or anything like that, or other departments, to be able to identify locations, right? Are they extremely necessary? Maybe not, but if we're trying to actually create certain locations or create some feature-based geometry and stuff like that, having a similar amount of a same amount of color, or the same color, sorry, in the trackers will enable you to select those as a group. So it's also used for grouping as well. So what we're going to do is we're going to select the trackers that we are going to colorize based on zones or areas. So what I'm going to do is I'm going to jump into, I could do it in this perspective, but we could jump into the quad perspective to kind of make it a little bit easier on us. And what I'm going to do is I'm going to go ahead and select some of the trackers that I know I need to change the color on. So I'm going to go ahead and say, for the window, I'm going to add just a little bit of this blue color. Um, then I'm going to go ahead and say, I want to select these guys right here. So I'm going to lasso the trackers on the perspective view very quick. And I want these trackers, not the ones from the wall, but just overall the ones on the element that I want to retexture. So let's go ahead and assign kind of a sort of purple on that. And then let's take the ones from the table, right? And then assign some colors to that as well. Um, like I said, is mostly the important areas or the important trackers that we might use to either rebuild elements or create elements that could be used or in any other type of operation. So like I said, it's type of like a grouping setup. Um, so in this case, let's go ahead and do this. I don't want to use these, none of these. So we're going to kind of keep the ones that are on the currently the table itself. Or close to that table. So right now these are the ones that we currently have after the lineup that we did. So let's go ahead and colorize those, and let's add like a yellowish kind of orangish color to it. Okay, so we have pretty much all our colorized trackers. So the next step will be applying the lens distortion operations. So what we're going to do with the lens distortion, the idea of the lens distortion workflow is to, let me go ahead and do this very quick. The idea of the lens distortion workflow is to go ahead and apply the lens calculation prior to doing any type of CG work or compositing work. So the idea is to be able to create an overscan plate that is undistorted that we could send to the CG department so they could work all their CG magic with all the 3D characters and everything in the 3D world without any type of distortion from a real lens. That way, when they send it back to us, based on that overscan, that means the image is a lot larger. We'll be able to take those images that were rendered in a larger format, apply the lens distortion to redistort them back into the original resolution and the original lens, and then composite it over the original plate. So it's extremely important to do this. So before we could do the export out into Nuke, we have to apply this lens distortion. So what we're going to do is, in order to see it a little bit easier and what we mean and what we're talking about, I'm going to go to the lens tab here. And I'm going to change this to the camera view. And you're going to notice right here, there's like a grid pattern enabled in there. So what I'm going to do is very quick. You could actually hide things in here. So you could hide the trackers, for example, and things like that if you don't want to see. So you can hide multiple things in here if you don't want to see some of the elements. I'm going to leave them on, but in this case, you will see the grid pattern in here, and the grid pattern has a slight distortion to it. And that's based on the lens calculation and the solve that we did for this shot. Based on all these trackers, that we have, the ones that are close to the edges and the ones that are in the center, we were able to calculate a distortion of 0.00813 on that lens. That is almost nothing, but that lens is actually close to a 25 millimeter, so there's a little bit of distortion still left in there. So now what we're going to do is we're going to apply this so this image expands a little bit and actually removes that distortion so we can do our CG work a little bit easier. So for this, what we're going to do is we're going to click on the lens workflow, and we're going to go ahead and apply. First, we're going to click on default to reset everything to its original, and we're going to apply redistort 2. Now, what is the difference between undistorted 1 and redistort 2? The undistorted 1 workflow is when you want to actually go ahead and undistort the plate and crop the plate to the usable area of the image. So that means no black edges or anything like that. So it will crop the image literally to no black pixels. But the problem with that is that we have original pixel data that gets thrown out on the edges of the image, and it's extremely important for compositors and for CG to also work with those images along the edge, because if we have something CG coming from the edge of the frame and we crop that before we actually work with it by applying the undistorted 1, what is going to happen is when we recomp, we're going to have a gap on that edge, and we will have to do a lot of other stuff to be able to get it to work right. So that's a problem. So for that, we're going to apply redistorted 2. And redistorted 2 was meant for applying the distortion or the redistortion to any element coming in, or to apply the lens distortion here by undistorting the original plate that we got here and applying an extra set of pixels on the edges, what we call, or otherwise known as, overscan. So you will notice that an image that is 1920 by 1080 could go a lot bigger. It could add 100 pixels to the edge, 16 pixels. It all depends how much distortion it has along the edge. So that's what we're going to do. We're going to apply redistorted 2. You want to apply it only once. So you're going to notice that the calculate distortion will shut off. You don't want to turn it again. You should do this after you have done all the solver and calculated all the errors. It's the same as the geometry idea, right? After you have done all your calculations, adding all your trackers and everything, and you're about to export anything, you want to do this process. There's another method that we do it earlier, but in this case, we're just going to do it this way. All right, so we're going to apply redistort 2, hit OK, and you're going to notice that the image will actually pop, and you're going to notice these little black edges along the edge. So right now what it did was it expanded the image a little bit larger, and you notice here that the edge actually went out. So you notice it's like fanning out, and the reason for that is because this is a wide angle lens and it had a barrel distortion in it. So we are around 25 millimeters, right? Close to 26 millimeter lens. So it has barrel distortion, so therefore when we actually remove that barrel distortion, it kind of tends to do a pincushion scenario, right? Where it actually pushes the edges towards the outside. If we had a telephoto lens, like a very high focal length, like let's say 500 or something like that, we will get a pincushion. And the effect of this will be opposite. It will actually collapse inwards towards the frame instead of outwards in these edges. So that's pretty much what we got right now. So now that this is said and done, we're ready to save. So I'm going to go ahead and save as. I'm going to save my next version. In reality, we usually have to set up version 1. We don't use version 3 unless it has been reviewed, but I'm going to save it as version 3. So just so you guys could see the progression. So after we have this, now we have all our color trackers, our lens distortion is applied. So now it's time for the export. So in order to export this, the first thing that we're going to do is we're going to export it to Nuke. So we're going to go to the export, and we're going to find Nuke current. And that's mostly the one that we're going to use the most. And we're going to go to our export folder, and we're going to label it with the current work that we're doing. So if we're in version 2 or version 3, we're going to label it that way. So I'm going to go very quick, and I already have one exported out for you guys, but I'm going to go ahead and delete it all to make sure that we can clean all those elements so it's a lot easier for you guys to see. So let's go in, File, Export again, and I'm going to go ahead and use New Current. Okay. So for this, we go to the export folder and we label the shot exactly the same as our naming convention on our synthesize file. And the reason for this is to keep files that are together all the way through the process, all the way through the pipeline, based on versions, based on labels, and everything like that. So it's a lot easier to know exactly where you're at. So let's go ahead and put that in, hit save. That's going to be our Nuke file. And we're going to be exporting it based on our frame sequence. So first frame is 1, that's fine. If we need to match frames, usually we'll turn that off, okay? Or we will do a time shift. But right now, you don't have to worry about that. Frame 1, you're good. STMap file, we're going to use the favorite format for Nuke, that is EXRs. By default, it comes TIFF. You want to change it to EXR. Okay. The export meshes, we want to export all these meshes so we could use it in Nuke to do our camera projections, our set extension, and everything else that we want to do with it. The sticky note will give us some information about where the file is coming from, the time that it was generated, and everything else. So from this scenario, everything else is said and done. So let's go ahead and hit OK. This is going to export out all the files. So let's go ahead and take a look at it very quick, and let's review the files. So when we go to these files, we go to the export, you're going to notice that you have all these files available to you now. Now, if you look at these cars, they're not labeled, right? It says car 1, car 2, car 3, car 4. Now, what about if we wanted to label these guys? Do you want to re-export it out? Yes, you can. But these are some of the files that get provided for you. So the LD will be the lens distortion. So essentially what this is actually undistorting the plate. And you're going to notice it looks kind of weird because this is an ST map. This actually constrains the U and V coordinates, and this will allow us to understore the plate while we're working inside of Nuke. So in Nuke, we will be working with the original plate. So instead of exporting the undistorted plate to Nuke, we will actually use the original plate and pass it through an ST map to undistort it while we work in the 3D system. It's the same idea as actually exporting an image sequence that is undistorting it and taking it into Maya and working in Maya with an undistorted plate. But this time, because we're going to Nuke, we don't have to do that step. So literally, we could do just this through an ST map. Now, the RD is the redistort map. If you notice, it's different, right? It doesn't have the edges at the top or anything like that. It covers the whole frame. What this guy is doing is, even though it seems like a simple map, this is actually a floating point value map. So essentially it has floating point data, which allows you to redistort now all the CG to match the lens distortion of the original lens or of the track. So this will allow the CG to actually perfectly match your track. Okay, and also all these will have different type of sizes. So if you look at the size of this, remember that our plate was 1920 by 1080. This is how much the overscan was. It's 2000 by 1124. Versus the redistort that scales it back down to 1920 by 1080, so it's putting it back to the original format. It's very cool. Now, these guys right here are all the cards that you guys generated out of Synthai, so they're 3D models, and this will be the Nuke script. Okay, so let's go ahead and re-export this very quick, and what we're going to do, I'm going to delete these 3 OBJs to show you how you can label these geometries a little bit better. So in order to label the geometries before the export, I'm going to go to the graph, right? Or camera and graph, so you guys could see it a little bit better. So I'm going to click on one of these objects, and there's a couple of ways of labeling it. The first one is by going through the 3D tab and double clicking on the actual object, and that way you can label it. So we could say table, okay? And then the other way of doing it is by, in the graph editor, you go click on meshes, and you have the 3 cards in here. So you just have to select this and say picture, and then this one will be the window. All right, so it's a little bit easier, and it keeps everything organized a little bit better, knowing exactly what is the mesh for when it gets into Nuke and stuff like that. So now that this is said and done, let's go ahead and save again. Let's go back to our perspective view, and let's go click on navigate so everything kind of frames back. Let's export it again. Now, because I'm exporting this again, I'm exporting to the same format, the same Nuke preferences and everything. You could go again and click on this guy right here and click on Nuke, or you could say export again. When you click on export again, it's essentially using the same Nuke settings, right? But essentially this is what it gets generated for us. So it's exactly the same settings that we used before, so that's why you don't have to set it all over again. But now it has the labels of each of the objects that we're using. All right, so the next thing that we're going to export before we go into Nuke and take a look at that is the preview movie. Now that we have everything here, the next thing that we need from you guys is the preview. So for this, it's very easy. When you get into the perspective view, you could be in quad or perspective, not in camera view, okay? It's not going to work in camera view. We're going to use the perspective view. You could go ahead and right-click on the view, and at the bottom, you can see Preview Movie. You could click on that, And the most important thing is clicking in to make sure that you know where to save it. We're going to have a Qt folder that you create. If you don't have it, just create one in the same folder structure that you currently have. And in there, give it the name of the movie. The name of the movie is going to be exactly the same name as your script right here. Now, later on, all this is going to change for deliverables, okay? But make sure that it's a QuickTime movie, not a bitmap sequence. By default, it comes in as a bitmap sequence. You want to change it to a QuickTime movie, okay? Hit save. Compression settings is H264, 16,000, that's okay. Anti-aliasing is going to be high. And then show all viewport items need to be on. This is part of your grading. Show grid, show square pixel output, and RGB included. That's it. After all that is said and done, you hit start and let it roll. All right, so immediately after it finished rendering, it's going to open the movie for you. My recommendation is go ahead and hit play and watch it. The important part is you are responsible to make sure that the quality of what you output is to the highest level. So it's very important that before you submit to me, you make sure that the quality of the output is good. And this is what will be a passing project for this, right? So if you look at this, we have everything that we need. In this case, our geometry and some of these trackers that we use a low value kind of serves as our zero weighted. In reality, they're not truly zero weighted, but they allow us to establish locations. We did the color trackers. We have some geometry in there that mark the area. We established the coordinate system in a different way to get the perspective right. So this is what I want to see, and essentially that gives you a better understanding of what Synthai is all about, and you kind of realize that every single shot is different, and the approach that you take to that shot might not be the same as a tutorial. So that's what the challenges are all about, is actually to kind of think about this tool in different ways as a compositor mode than anything else, because it's what we have to do later. Think of Synthai as just a simple step, not as an overall whole project. It's actually very simple, very straightforward. What you got to do is nothing complicated. So essentially, is after you get it, just think of it as a step to do the comp later down the road. All right, so after we have this, it's very important to save it, and we're going to have the save version there. We're going to close it up. Now, you're going to have all your elements already on the export, the Qt. You're going to have the movie right there, and you're going to have the SNI. So what you got to do next? Well, in the deliverables section, I'm not going to show you everything that you have to do in FSO. Just follow your FSO guidelines. But my recommendation is before you do anything, don't just go ahead and copy the elements that you need into the deliverables section, right? So have a copy of each of the elements that you need to deliver. So in order to do that, just refer back to the section of in FSO of deliverables, so you know what you have to deliver. Now, in the case of the nuke script, you could group all these into one NK folder, but in reality, the only thing I need is the NK file right here, and that's pretty much about it. I don't need anything else. If by some reason I need all this, that's what we have you actually output it, so you could use it later on, and also you could actually try out everything that you need for this project as well and understand how things work. But in reality, I need this, the .nk, and that pretty much is it. If by some reason we ask for Maya export, you could also do it. At this point, no need for that. We will take it off maybe or maybe not. So we will ask you, we'll let you know on lecture or in GoToMeeting. All right, so now that we have those three, that follow the FSO guidelines for deliverables. Make sure that you compress it and you do everything else that you need with those. And that pretty much will get us in that process. So that pretty much will be it for this. And essentially, I hope you enjoyed this project and kind of go ahead and do all the other challenges and kind of enjoy it. It's just only a simple step and something to have fun with. All right, have a great one. See you in lecture. Bye-bye.